Hello and welcome to our demonstration of SpaceClaim Ingénierie. Today I'm going to show you three things: how you can quickly draw new design concepts in 3D, how SpaceClaim's pull, move, fill, and combine tools let you work easily with solids, and how SpaceClaim enables you to communicate in 3D with CAD users and the extended design team. In this example, I'm going to perform the conceptual design of a cart used to hold the computer system and robotic arm for a medical scanner. I'll be playing the role of a conceptual engineer or industrial designer. To begin the medical cart, I'll start by drawing some simple shapes, just like you would do on the back of a napkin, to get a general idea for the size of the concept. We'll need to make a base, a chair, a workspace or desktop, and a space for a modular robotic arm. Also notice that these aren't just simple sketches. I'm making 3D direct parts, as you can see in the bottom right-hand corner of the screen. This means that as I finish making my layout, it's actually a 3D layout, so I'll never have to worry about remodeling in 3D. Moving from cross-section to 3D, let's look at some of SpaceClaim's tools and how we can use them to rapidly make changes to our design. Pull and move allow me to create and change geometry by directly selecting on our design. Pull can thicken our chair or add rounds to edges. Move acts slightly different. Move allows you to translate selected geometry or rotate it by the move anchor. SpaceClaim also allows you to change the structure of your model as well. We can cut solids apart or combine them together to go from a few separate solids or parts and quickly change it into assembly, which we can see in our structure tree in the upper left-hand corner. By doing this, we can quickly work top-down and flesh out our design. In addition to creating our design from scratch, we can incorporate designs from many different systems. We have a stock office chair that we could bring in to use for our concept design and replace the keep-out we've created. This chair comes in from SolidWorks, but we also have a modular arm that we had designed for a previous cart. That design was outsourced to a supplier, so it comes in from ProEngineer. In SpaceClaim, we can work with designs from many different systems inside of one window. In fact, we should probably adapt our stand so it fits with our modular arm. While still in the conceptual phase, we want to explore many different design options and not have to plan it out from the beginning. In SpaceClaim, we don't have to worry about CAD systems constraints. We can adapt as we see fit. You can quickly see how we've converted our cylinder to fit our imported design. Once we create our arms, we can copy pieces on our design to quickly create the mount for them. All we have to do after this is assemble our arm into place, and it fits nicely in the spot we've made. After the fact, we can also adjust the stand we've created, changing the size one way or the next, or snapping it to the same size as our imported piece. We might decide that in addition to all the components we've made, we should also have a built-in monitor. This can be made without even needing to enter into a sketch. By simply reusing edges and faces we already have, we can get the basic outline for the size and shape we need. Then, after coloring a few faces, it looks good to go. Now we'll look at a tray and work on it in section mode. In SpaceClaim, making changes in a cross-section is just as easy as making them in 3D. A point represents an edge, and a line represents a face. This allows us to change the geometry freely throughout our modeling. After making some basic edits, we can finish the tray off by adding some detail. With some more rapid edge manipulation, we can add the finishing touches here. Now that the tray is completed, the last piece is to finish the base. It'll be easy to see if we open it up as its own component and look at it there. To add some stability, we should probably widen the base. The neat thing about SpaceClaim is that we can approach this problem in a number of different ways. We could probably sketch to add some geometry and thicken it, or I could experiment with splitting the base apart from one solid into two. In addition to moving solids a precise distance, we can also reuse geometry by copying surfaces back out. I can work with surfaces just like I work with solids. Take some edges, drag them around to change the profile, and then when I'm done, we can blend between them without ever exiting our tool. This base is already starting to look much better than our previous one. If we'd like, we can add some more stability by creating some big rounds and drafting our surfaces out. Let's add a little more detail to the other side of the base as well. Remember, we can directly select on faces or edges to change them, or even create a full round on the back. After creating this base as its own component, we can go back to the overall assembly and notice that everything is updated there as well. To finish the cart, we can move our base and chair around, which will also give us more room for the tray. Now that we've completed our first concept of the cart, let's fast forward a bit to where some rounds have been added, parts have been shelved, and an ergonomic model has been placed in to help us size up some of the components. Now we're ready to do some investigative studies from an engineering standpoint. We can add or change some of the materials on the components from our material library, so we can then check the model's center of gravity, making sure it's not too high or off-center. It would also be nice if we could add a few 3D dimensions and do a quick human factors analysis. We can add the eye level of our model and a few dimensions for the tray and the monitor. The key thing to remember is that these dimensions are here to help us create and change the model and not to constrain things. We can still freely change the height of the components, or if we like, use the dimensions we've placed in the model to drive them. Moving the monitor up to eye level, or moving the tray back down to a more appropriate height. After completing our investigative studies, we can also view this in our engineering notebook. This is where I like to include information about the design. Here we can view it, change formats, or add in extra views, or include a bill of materials for the components that will make up the design. This is associative back to the structure tree we've made, which means if I change a component's name, both will update. I can also include other information by inserting it into our design. Here we can bring in a picture which shows a final version of the cart rendered so we can see what it will look like after manufacturing. Now this might look like a simple image too, but in SpaceClaim, we can insert videos in our model in addition to images to clearly convey messages for how we want things to be assembled or to explain how we created certain objects. Here we can see the cart being made from quick edge manipulation, importing parts from different systems, or doing our investigative studies. I hope you've enjoyed our demonstration for SpaceClaim Engineer using conceptual design. Here's what I hope you took away. You can create 3D models by drawing in cross-sections without messing around with sketches. SpaceClaim lets you open and edit 3D solid data regardless of origin. Using SpaceClaim, you can quickly